Searching a graph. First off, what do I mean by searching a graph? When I say searching, I don't mean the usual definition where we're looking for a certain value amongst a group of values. That's the definition we use when we're talking about binary search trees and linked lists and array lists and so on and so forth. With a graph, when I say search, what I mean is if my starting point is vertex A, I want to know which vertices are reachable from that vertex and which vertices are not. So to find that out, we have to perform a search to determine which vertices are reachable from my starting point. There are two ways to do that. We'll discuss one of them in this video, and then we'll discuss the other one in the next. The first one is called a depth first search. So how do we perform a depth first search? First step, go to your starting point, and then mark that vertex as visited. Then, push that vertex onto a stack. Next, visit an adjacent vertex. Mark that vertex as visited. Then repeat steps 2 and 3. Push B onto a stack, then visit an adjacent vertex. Push F onto the stack, then visit an adjacent vertex. Then push G onto a stack. We repeat this process until we encounter a vertex whom has no other adjacent vertex that we have not already visited. In this case, that vertex is G. So now we're going to begin popping the stack. We're going to keep popping the stack for as long as the current top value of the stack has no unvisited adjacent vertex. So we're going to pop G, and that's going to take us back to the vertex we visited prior to G. We see F has no unvisited adjacent vertex, so we're going to pop F, and that'll take us back to B. B also has no unvisited adjacent vertex, so now we're going to pop B, which will take us back to A. We see A does have another unvisited adjacent vertex, so we're going to go there. We're going to go to C, then push C onto the stack. Then we see that C has no other unvisited adjacent vertex, so now we're going to pop it and immediately return back to A. Then we're going to visit A's other unvisited adjacent vertex, which is D. We're going to push D onto the stack, then visit D's other unvisited adjacent vertex, H, push it onto the stack, then visit H's other unvisited adjacent vertex, push I onto the stack. Then we see I has no other unvisited adjacent vertex, so we're going to pop it and work our way back. H has no other unvisited adjacent vertex, so we're going to pop H and go back one. D has no other unvisited adjacent vertex, so we're going to pop D and then return back. A still has one other unvisited adjacent vertex, that is E, so we're going to visit it, push it onto the stack. Now clearly E has no other unvisited adjacent vertex, so now it's time to pop it, return back to A. A now no longer has any unvisited adjacent vertexes, so now it's time to pop A. Once the stack is empty, you know you've reached the end of the algorithm. Now, notice that the algorithm completed without us ever visiting J and K. That tells us that J and K is not reachable from vertex A. And then lastly, in summary, the order of visitation in this case was A, B, F, G, C, D, H, I, and E. This was the order that the vertices got marked as visited as we performed the algorithm.